All right, let's dive in. Today, it's decision theory. Basically, figuring out the reasoning behind choices we make. And those choices, well, they can be anything, right?
Yeah, from the small stuff like, should I answer this email or get another coffee, to the big life-altering decisions. And for you, listening as a philosopher, you're already thinking about reason and choice all the time.
It's kind of our bread and butter, isn't it?
Right, and decision theory takes these ideas, the ones you're already wrestling with, and tries to make them more, well, formal. It's like a way to analyze the logic behind what we prefer, what we see as good.
So it's not about telling people what they should want, but figuring out if their wants actually make sense.
Well, exactly. Like, are they consistent? Do they hold up when you poke at them a bit? That's what normative decision theory is all about. It's about setting some ground rules for what counts as rational preferences. And a big part of that, of course, is how we handle uncertainty.
Because, let's be honest, most decisions aren't made with perfect knowledge, right?
No, not at all. Uncertainty is everywhere. And the way we deal with that in decision theory, the most common approach, is something called expected utility theory. EU theory for short. It basically says you should choose the option that, on average, promises you the most desirability, the most value, but, and this is important, based on your own judgment, your own beliefs about how the world works.
Okay, I'm following so far. Now, to guide us through this deep dive, we've got some really rich material. We're looking at excerpts from the Stanford Encyclopedia of Philosophy on decision theory.
A great resource. Really lays out the foundation, the main arguments, the debates going on in the field. A great starting point for this conversation.
It is. So our mission today, if you choose to accept it, is to really get a grip on what makes a preference rational. We want to unpack this expected utility theory, see how it's built, what makes it tick.
And I think especially for you as a philosopher to dig into the assumptions behind EU theory and, maybe see where it falls short, where it doesn't quite capture the whole picture.
Okay, let's break it down, starting with the basics. Preferences. What exactly do we mean by that word in decision theory?
Well, when we say someone prefers option A over option B, we're simply saying that they judge A to be, let's say, more desirable, more worthy of being chosen than B. It's about how you rank things, not just the value of each thing on its own.
It's about comparisons.
Exactly. Now, when we're dealing with a whole bunch of options, not just two, this ranking becomes what we call a preference ordering.
So if I've got options X, Y, and Z, I might prefer Z the most, then Y and X the least. That's my preference ordering.
Exactly. And we use these symbols, like greater than or less than signs to represent these relationships.
Right. We've got the symbols for weak preference, strict preference, and indifference.
Yes. So A, weak preference for B, just means you think B is at least as good as A. Strict preference means A is definitely better in your view. And then there's indifference, where you basically see A and B as the same, value-wise.
So we've got this ordered list of preferences. But when does it become rational? Are there rules for that?
There are. Two core axioms are often considered fundamental: completeness and transitivity.
Completeness, I feel like that's a pretty strong requirement. You're saying you have to have an opinion on everything.
In a way, yeah. Completeness means for any two options, you've got to be able to compare them. You prefer one, the other, or you're indifferent. No just shrugging and saying, I don't know.
Okay, but think about it philosophically. Like if I'm comparing, let's say, improving literacy for two people versus extending the lives of two people, those are such different things.
Yeah.
Can I really be forced to have a preference or even be indifferent?
You're pointing to a very real philosophical debate here. Does completeness actually make sense in every situation? Especially when you're dealing with values that are so different. It gets tricky, right?
It does. It feels like sometimes acknowledging the difference, the incomparability, is the most honest answer.
And that's where the idea of coherently extendable preferences comes in. Basically, even if your preferences aren't complete right now, you should be able to fill in those gaps later without contradicting yourself or violating the other core principles of rationality.
So it's not that you must have a complete ordering at all times, but that your preferences should be, let's say, expandable in a way that makes sense.
Right. Now, on to the second big axiom, transitivity. If you prefer A to B and B to C, then you should also prefer A to C. On the surface, that seems totally obvious, but
there are always deeper layers, aren't there? Especially in philosophy.
There are. See, the challenge to transitivity often comes when the options we're comparing are really different from each other. The idea is that what we focus on, what seems most important in the comparison, can actually shift depending on which two things we're looking at.
So context matters. Like if I'm comparing A and B, maybe speed is the key thing. Then with B and C, it's safety that jumps out. But with A and C directly, it's something else entirely, like, I don't know, aesthetic beauty.
Yeah, and if those things that stand out are different each time, it's not clear that your overall preferences have to be transitive. Maybe the very idea of better is changing with the context. Temkin, for example, makes this argument very powerfully.
Like the ruler you're using to measure keeps changing its markings.
Exactly. Now, there are philosophers like Broom who argue that transitivity is just built into what better means. If being rational means judging what's better, then transitivity is a non-negotiable part of the deal.
So you've got this debate. On one side, the stability of better than, no matter the context. On the other side, the idea that our judgments can shift based on what we're paying attention to at that moment.
Right. But then there's a more practical, maybe even a bit scary argument for transitivity, the money pump argument.
Okay, this sounds like something philosophers might actually worry about.
Imagine your preferences aren't transitive. So you prefer A to B, B to C, but then C to A, completing the loop. Now, let's say you have A and someone offers you B for it. Since you prefer B, you might even pay a little to make the trade. Then someone else offers you C for B. Again, maybe you pay a bit because you prefer C, but now you're willing to pay to get A back because you prefer it over C.
And you're back where you started, but poorer.
Exactly. You've been pumped of your money. Intransitive preferences make you exploitable, you see. You end up making a series of choices that, by your own standards, leave you worse off.
That's a strong argument for transitivity, especially for a philosopher who cares about, avoiding self-contradiction and not making decisions that just make things worse.
Agreed. So let's say, for now, that we accept completeness and transitivity as generally true for rational preferences. How do we move from just ordering our preferences to actually putting numbers to them?
Because numbers let us measure things, right?
Yeah.
Make more precise comparisons.
Yeah. Exactly. And that's where utility functions come in. It's about assigning a numerical value to each option that reflects how desirable it is to you.
And there are different types of utility functions, right? Starting with the simpler ordinal ones.
Right. Ordinal utility is just about the ranking. The numbers themselves don't mean much beyond their order. So if C has a utility of 5, B has 3, and A has 1, all that tells us is you prefer C to B and B to A. It doesn't tell us how much more you prefer them.
So if I change those numbers to 10, 6, and 2, it wouldn't matter as long as the order stays the same.
Not for ordinal utility, no. It's only the order that's important. And there's a formal theorem. If your preferences are complete and transitive, you can always represent them with an ordinal utility function.
Neat. But the problem is, ordinal utility doesn't tell us the intensity of the preference, right? How much stronger one preference is compared to another.
That's the limitation. Especially when we start talking about choices with uncertainty, like lotteries or gambles. Ordinal utilities can't really handle those situations well. The example in the text shows how you can get nonsensical results if you try to calculate expected utilities based solely on ordinal values.
So to really deal with uncertainty, we need a more powerful tool. Cardinal utility.
Exactly. Cardinal utility tries to capture not just the order, but the distance between the preferences, how much more you prefer one thing to another. It's about the intensity.
But how do you even measure that distance? Desire feels so personal, so subjective. How do you put a number on it?
This is where lotteries come in. Let's say you prefer Amsterdam to Bangkok to Cardiff for a holiday. That's the ordinal ranking. But to get a cardinal measure, we imagine a lottery. Let's say you could win a trip to either Amsterdam or Cardiff. What probability of winning Cardiff would make you indifferent between that lottery and a guaranteed trip to Bangkok?
So you're using my willingness to gamble as a way to figure out how much I value Bangkok relative to the other two.
Exactly. The basic idea, which goes back to Ramsey and von Neumann and Morgenstern, is that by looking at what risks you're willing to take, we can get a sense of the intensity of your preferences.
So if I'm almost indifferent between Bangkok and a lottery, with a very high chance of winning Cardiff, it means Bangkok is pretty close in desirability to Cardiff for me.
Yes. And if we set the utilities of the best and worst outcomes, Cardiff and Amsterdam, in this case, to 1 and 0, respectively, then the probability of winning Cardiff that makes you indifferent to the lottery becomes the cardinal utility of Bangkok.
That's really clever. So in this case, if you're indifferent at, say, a 75% chance of winning Cardiff, then the cardinal utility of Bangkok would be 0.75.
You got it. Of course, we're assuming here that you're evaluating the lottery based on its expected utility, which brings us to a crucial point. Is that assumption justified?
Yeah, that's a big question. Are we just assuming people think in terms of expected utility when they make choices?
The von Neumann-Morgenstern VNM representation theorem answers this. It shows that if your preferences over lotteries follow certain rules of rationality, then you must be acting as if you're maximizing expected utility.
So it's not just an arbitrary assumption, it's a consequence of something deeper.
Exactly. It turns out that expected utility maximization actually follows from more fundamental principles of rational choice.
Fascinating. Now, to be clear, when we talk about expected utility, we're talking about taking the utility of each possible outcome, multiplying it by the probability of that outcome happening, and adding those all up, right?
That's the formula, yes. And what the VNM theorem shows is that if your choices between lotteries follow certain axioms, then your preferences must align with this calculation of expected utility.
Okay, and some of those axioms are the ones we talked about already. Completeness and transitivity. What else is there?
Two more key ones: continuity and independence.
Continuity, does that have something to do with probabilities?
Yeah, it basically says that if you've got three outcomes, A, B, and C, and you prefer A the least and C the most, then there must be some probability of getting C that would make you indifferent between a guaranteed B and a gamble between A and C.
So no outcome is so bad that you wouldn't take a tiny chance of it if it meant a good chance of getting something really good.
That's the gist of it, yeah. Although there are some thought experiments that push on this, right? Like, would you really risk death, even a tiny chance of it, for a minuscule gain? It shows that even intuitively appealing axioms can lead to some strange conclusions.
True, true. Okay, and then there's independence, which I have a feeling is a bit more controversial.
You'd be right. It's a big one, and it trips people up. Basically, independence says that your preference between two options shouldn't change if you add a third option to both of them, mixed in with the same probability. It's like your preference for coffee over tea shouldn't be swayed by the fact that both now come with a 10% chance of getting orange juice instead.
Okay, I think I get it. But the LA paradox comes in here, right? Didn't we talk about that before?
We did, and it's a famous example of how people's actual choices often violate the independence axiom. In the LA paradox, people are asked to choose between different lotteries, and their choices often show that the presence of a sure thing option messes with their preferences in a way that independence doesn't allow. It's like the psychological pull of certainty outweighs the pure calculation of expected value.
And the common explanation is that people hate the feeling of missing out, of regret.
Oh.
They'd rather take a sure thing, even if it's slightly less valuable on average, than risk getting nothing at all.
Exactly. It's a very human thing, but it throws a wrench into the neat logic of EU theory.
So the VNM theorem shows us the beauty of EU theory, that maximizing expected utility flows naturally from these core axioms.
Right.
But the LA paradox reminds us that people, well, they don't always behave so neatly.
It highlights the limitations of any formal model, right? Human psychology is messy. But that doesn't mean the VNM theorem is useless. It's still a powerful framework for understanding rational choice when the probabilities are clear, well-defined.
Okay, so VNM handles cases where we know the exact probabilities. But most decisions in life are made with uncertainty, where we don't have those nice, precise numbers. What does decision theory say about that?
That's where we move from lotteries to real-world decisions, from risk to uncertainty. And that brings us to subjective expected utility theory, or SEU, sometimes just called EU theory too. The big idea here is that you don't need objective probabilities handed to you. You can have your own beliefs about how likely different events are.
Though it's about combining what we want with what we believe.
Exactly. Your utility function captures how much you value different outcomes, and your probability function reflects your own confidence in different states of the world happening. And SEU theory says you should still choose the option that maximizes expected utility, but now it's calculated based on those subjective probabilities.
And there are different flavors of SEU, right? The text mentioned Savage and Jeffrey.
Yes. Savage, in his famous book, The Foundations of Statistics, developed a really influential theory. He basically lays out a bunch of axioms that, if they hold, guarantee you can represent an agent's preferences using a unique probability function and a cardinal utility function. It's a really powerful result.
And in Savage's world, we're talking about acts and states of the world, right?
Right. Outcomes are the things that ultimately matter to you, the things you care about. States of the world are the things you can't control, the background conditions that affect what happens. And an act is just a way of linking those two. It says, if this state of the world happens, then this outcome will occur.
So it's like having a huge mental table where each row is a state of the world and each column is an act, and the cells tell you what outcome you get in each situation.
That's a great way to visualize it. Savage's theory is all about having preferences over these acts. And what's remarkable is that if those preferences follow his axioms, we can actually figure out both your subjective beliefs, your probabilities for each state of the world, and your desires, your utilities for each outcome.
And Savage even defines the concept of belief in terms of preferences.
Right. He does. He argues that generally you would prefer to bet on something you think is more likely. So by looking at your betting preferences, we can infer your beliefs about the likelihood of different events. Of course, there are philosophical issues with this, especially if someone is just bad at making choices or if they don't really care about any of the outcomes.
Okay, so Savage has these acts, states, and outcomes, and he's got a bunch of axioms.
Yeah.
What are some of the key ones besides, completeness and transitivity?
Well, one important one is the sure thing principle. It basically says that if two acts lead to the same outcome in a particular state of the world, then your preference between them shouldn't depend on that outcome.
So if both options give you the same thing in one scenario, then you should just focus on what happens in the other scenarios where they differ.
That's the idea, yeah. It sounds pretty intuitive, but it runs into trouble with the Allais paradox again. It turns out that the presence of that sure thing outcome can still influence people's choices, even if it shouldn't, according to the sure thing principle.
So maybe our intuitive ideas about rationality don't always match up with how we actually behave.
It seems that way. Another issue with the sure thing principle is that it relies on the assumption that the act you choose doesn't affect the likelihood of different states of the world. But in many cases, that's just not true.
Yeah, like if I choose to exercise more, that will probably affect my future health. So the act and the state are not really independent.
Right. So Savage's theory is powerful, but it has these assumptions that can be a bit shaky when you look closer.
And that's where Jeffrey comes in, right? Offering an alternative to Savage's theory.
Exactly. Jeffrey takes a different approach. Instead of separating things into acts, outcomes, and states of the world, he focuses on propositions.
Propositions as in statements that can be true or false.
Exactly. So in Jeffrey's framework, you have beliefs about how likely different propositions are to be true, and you have desires about whether you want them to be true.
Yeah, so like I might believe that it's likely to rain tomorrow, and I might also really dislike the idea of it raining tomorrow.
Exactly. And even the actions you take are seen as propositions, things that you have the power to make true. It's like looking at your whole decision from a more detached, almost third-person perspective.
That's interesting. And how does this change the way we calculate desirability? What's Jeffrey's formula?
Well, for Jeffrey, the desirability of a proposition depends on the desirability of the different ways it could be true, weighted by how likely those ways are, given that the proposition is actually true. It's a bit more complex, but it avoids some of the problems of Savage's theory.
Like the sure thing principle.
Yeah, Jeffrey's theory doesn't need that principle, because it allows for the possibility that the act you choose can affect the likelihood of different propositions being true. It's a more flexible framework that doesn't need the assumption of independence between acts and states.
So it's more, let's say, realistic in a way.
You could say that. It's more in line with how we often experience decision problems. We don't always think in terms of neat, independent states of the world.
But there was a downside mentioned, something about uniqueness.
Yes, that's a big difference. While Savage's theorem guarantees a unique probability function representing the agent's beliefs, Jeffrey's theory doesn't. Even if you follow all of Jeffrey's rules of rationality, there might be multiple different ways to represent your preferences with probabilities, and those different probabilities might not agree with each other.
That seems like a problem, especially if you're trying to figure out what someone actually believes based on their choices.
It is, for some people. For those who want a very neat behaviorist account of belief, it's a big issue. But philosophers like Joyce have argued that maybe this lack of uniqueness is a good thing. Maybe it reflects the fact that our beliefs aren't always so perfectly precise.
So some fuzziness is allowed.
Exactly. And there are ways to get more uniqueness in Jeffrey's framework by adding extra rules or by expanding the kinds of things the agent has preferences over.
So both Savage and Jeffrey give us frameworks for linking preferences to beliefs and desires, but they do it in different ways, with different strengths and weaknesses. It's like two different tools for the same job.
A good analogy. And the implications of EU theory in its various forms go beyond individual choices. It has a lot to say about what it means to have rational beliefs and desires in general.
Okay, let's talk about beliefs first. What's the connection between EU theory and this idea of Bayesian decision theory?
Well, Bayesian decision theory basically means making decisions using EU theory, where your beliefs are represented as probabilities that follow the rules of probability theory. So, if you're on board with EU theory, you're generally committed to having probabilistic beliefs.
So it's not just that our beliefs feed into the calculations, but that the beliefs themselves have to have a certain structure.
Right. For some, like Savage, the connection is even deeper. They argue that your beliefs are essentially defined by your preferences over certain kinds of gambles. But, as we said, that's a strong view, and not everyone agrees with it. A more moderate view is that beliefs influence preferences, but they aren't completely determined by them.
Now, why should our beliefs be probabilistic in the first place? Is there a good reason for that?
There's a lot of debate about this. Some philosophers, like Renard, argue that it's mainly a matter of practicality. If your beliefs aren't probabilistic, you might end up making decisions that are guaranteed to make you worse off no matter what happens. Others, like Joyce, take a more epistemological approach, saying that probabilistic beliefs are the best way to make sure your beliefs are as close to the truth as possible.
So two main arguments. Avoid bad outcomes, or try to get as close to the truth as you can.
Exactly. And the Bayesian approach, which goes hand in hand with EU theory, puts a lot of emphasis on updating your beliefs when you get new evidence. This leads to the idea of the value of information, which is basically figuring out how much it's worth paying to get more information before you make a decision.
And Bayesianism is everywhere these days, right? Not just in individual decision-making, but also in science, statistics, all sorts of fields.
Absolutely. It's become a major framework for thinking about evidence, experiments, and how we revise our theories about the world.
Okay, so EU theory has a lot to say about beliefs. What about desires? What does it tell us about those? The text mentions some criticisms coming from seemingly opposite directions.
Yeah, one criticism is that EU theory is too loose, too permissive. It seems like you can always find a way to make any weird preference seem rational by just describing the situation differently.
So it's like, no matter how crazy someone's choices are, you can always cook up a story that makes them seem like they're maximizing expected utility.
Yeah, that's the worry. And it raises the question, does EU theory actually put any limits on what we can rationally desire? There are two main responses to this. One is to say, okay, we need to add more constraints, rules about what kinds of preferences are even allowed. The other response is to say, maybe EU theory isn't about dictating what we should desire, but just about describing the relationship between beliefs and desires in a coherent way.
And the other criticism was that EU theory is too restrictive when it comes to desires.
Right. This often comes from ethical theory. Many philosophers worry that a framework focused only on consequences can't capture all the nuances of morality. Like, what about absolute rules? Things you should never do, no matter what the consequences might be.
Yeah, like don't lie or
Yep.
don't harm innocent people. Those seem like they go beyond just calculating the best overall outcome.
Exactly. And it's not clear how EU theory can accommodate those kinds of moral principles in their purest form. Now, some people argue that you can build these ethical considerations into the description of the outcomes themselves. So the outcome of lying would include not just the consequences of the lie, but also the fact that a moral rule has been violated.
So like breaking a moral rule adds a kind of negative value to the outcome, even if the consequences themselves are good.
Right. But even that approach has limits. Some things just seem wrong, regardless of the consequences or how you describe them. And concepts like supererogation actions that are good but go above and beyond what's morally required are also tricky to fit into EU theory.
It seems like EU theory is a bit too focused on just choosing the best option, not on the broader ethical landscape of choices.
It does have that focus, and it's led to some interesting debates. For example, the philosopher David Lewis used EU theory in a famous argument against the idea that beliefs about what's good can motivate us directly, without any underlying desires. His argument is controversial, but it shows how these formal tools from decision theory can be applied to deep philosophical questions about the nature of belief and desire.
Okay, so EU theory is powerful, but it's got its issues. And the text you gave us spends a lot of time on these criticisms, the challenges to this dominant view of rational choice. Where should we start unpacking those?
Well, let's look at risk and regret first. Remember the Allais paradox. That highlights how people sometimes value outcomes differently depending on what else could have happened. The possibility of regret, of feeling like you made the wrong choice, can really mess with your preferences.
Yeah, standard EU theory doesn't seem to have a place for regret, does it? It's all about calculating expected utility in a cold, detached way.
Right. And the standard response from EU theory defenders is to say, okay, if regret matters to you, then you should just include it as part of the outcome itself. So the outcome of winning nothing in the Allais paradox should really be winning nothing plus the feeling of intense regret.
So you just redescribe the outcomes to include those psychological factors.
Exactly. But the problem is, if you can always redescribe things to make any choice seem rational, then the theory doesn't really tell us much, does it? It's like, what's the point if you can always twist things to fit?
Right. It starts to feel a bit like cheating. So are there alternatives that handle risk and regret in a more, let's say, honest way?
There are. Laura Buchek, for example, has this risk-weighted expected utility theory. Her idea is that the value of an outcome isn't fixed. It depends on the other outcomes you could have gotten and your overall attitude towards risk. She adds a risk function into the expected utility formula to capture how willing you are to accept risk.
That's interesting. So it's not just about the values of the outcomes themselves, but about how those values change depending on the context of the gamble.
Exactly. Other philosophers like Bradley and Stefansson have extended Jeffrey's theory to include counterfactuals, the what-if scenarios, as a way to model regret. And they've also looked at how to distinguish between risk aversion and attitudes towards the quantity of a good, because those can get mixed up in standard theories.
Okay, so there are ways to go beyond standard EU theory and make it more sensitive to how people actually experience risk and regret.
Right. Now, another big challenge, as we've touched on, is the completeness axiom, the idea that you always have a definite preference between any two options.
Yeah, we talk about how that can get philosophically tricky when the options are very different or when you just don't have enough information.
Yep. Exactly. And in those cases where your beliefs and desires are fuzzy or imprecise, it makes sense to move away from single, precise probability and utility functions. Instead, you can use sets of these functions to represent that uncertainty. The more unsure you are, the bigger and more diverse those sets become.
So it's like admitting that you don't have all the answers, that there are multiple ways to see the situation.
Exactly. And this leads to different decision rules for dealing with this imprecision. One basic idea is to avoid options that are worse in every possible scenario, the ones that are EU-dominated. But beyond that, there are different approaches.
Like some rules are more cautious, some are more optimistic.
Right. There's the Maxman EU rule, which says, focus on the worst possible outcome in each case and choose the option that does best in those worst-case scenarios. Very cautious, right? Then there are rules that try to factor in your confidence in different probabilities and utilities, giving more weight to the ones you're more sure about. And there are rules that look at how much uncertainty an option can tolerate before it becomes unacceptable.
It seems like there's no one right answer in these situations.
No, not really. It depends on the context, on what you value, on how you approach uncertainty. It's an ongoing area of research.
Okay, and finally we have unawareness, which feels like a very philosophical problem. It's about the things we don't even know we don't know.
It is. And it poses a fundamental challenge to standard decision theory, which usually assumes we know all the possible outcomes and states of the world. But in reality, there might be whole categories of things we just haven't considered.
Like there's what we know we don't know, and then the big one, what we don't even realize we're missing. And traditional decision theory only seems to deal with the first two.
Right. And it's helpful to distinguish between unawareness of unawareness, where you don't even realize you're missing something, and awareness of unawareness, where you at least suspect there might be more to the story.
That first one, unawareness of unawareness, that seems impossible to model, right?
Mm-hmm.
How can you include something in your decision if you don't even know it exists?
It's a tough one, yeah. But some researchers have started looking at how our reasoning changes when we suddenly become aware of something new. Like, how do our probabilities shift? Do we adjust everything, or do we just kind of squeeze in the new information?
But awareness of unawareness, that seems more relevant to how we actually make decisions, right?
Right.
Like, if I know I might be missing something, how does that affect my choices?
Exactly. There are models that try to represent agents who are aware of their own potential unawareness. The tricky part is figuring out how to assign probabilities and utilities to things you don't even know about. Some researchers think we basically use the same reasoning processes for known unknowns and unknown unknowns, just adjusting our confidence levels. Others think we use our past experiences of becoming aware of new things to make guesses about what we might be missing.
It's like trying to guess the shape of something by looking at its shadow.
A good metaphor. It shows how limited any model is that assumes perfect knowledge. The real world is full of unknowns, and we have to find ways to deal with that.
Okay, let's move on to our last big topic, sequential decisions. Choices made over time, not just in one isolated moment. How does that change things?
Sequential decisions add a whole new level of complexity. Instead of thinking about choices as single events, we have to use decision trees to represent these branching paths, where each choice opens up new possibilities.
It's like a choose-your-own-adventure book, where each choice leads to a different page, a different part of the story.
Exactly. And this raises questions about how choices made at different times relate to each other. Like, if you make a series of rational choices at each step, does that guarantee you'll end up with a good outcome overall?
Not necessarily, right? Like, you could take a series of seemingly good steps that lead you down a path you